Okay, so what we're going to talk about now is COGEH. So I've split COGEH into two parts. It's quite a comprehensive document. So part one, we'll be going through definitions, reserves and resources. So just to start out, I'll start with some basic concepts, then I'll move into the classifications, which is talking about that box that we saw in the last presentation. Talk a bit about Petroleum Initially-In-Place, the resources, and finish it off with the official definitions of reserves. The reference materials, all the information in the next two presentations are coming out of the Canadian Oil and Gas Evaluation Handbook, and I've specifically outlined a section that was added that I mentioned briefly, added in 2014 for resources other than reserves, which is really getting into unconventional play types and expanding definitions to account for unconventional evaluations. So what we're going to be talking about is how we define resources and reserves. We're going to start out with some high-level, non-technical concepts that are hopefully a little easier to understand than the official definitions. So they may not match exactly the definitions that you would find inside the documentation. So petroleum is simply defined as naturally occurring mixture of hydrocarbons in gas, liquid, or solid phases. So that's pretty standard. We've got most types, pretty much all the various hydrocarbon types. We deal with them regularly in Canada and Alberta especially. Full spectrum, oil, natural gas, bitumen, CBM, related substances, byproducts like ethane, butane, pentanes, etc. Accumulation is simply an individual body of petroleum in a reservoir. So accumulations are really the reservoir themselves. They're what when we get talking about discovery, known and unknown accumulations. So it's an important term, but just understand what it means. So this is really just talking about a body of oil and gas. Chance of discovery, when we get talking about chance and risk, you're going to see chance of discovery and chance of commerciality and chance of development. Chance of discovery is the chance that exploration activities will confirm the existence of hydrocarbons. So discovery is really penetration by a wellbore combined with something like logs, production tests that confirms the presence of hydrocarbons. So when we're talking about chance of discovery, it's the chance of that occurring. Chance of development, probability that once you have discovered an accumulation of oil and gas, you will proceed with development of that asset. And this chance of development, we'll talk a bit more about it later, but it has a whole bunch of different elements ranging from economics to royalties to social and political licenses, that kind of stuff. Chance of commerciality is simply the product of chance of discovery and chance of development. So chance of commerciality, again, you're going to see when we get into contingent prospective resources and reserves, they all interact a bit differently. But chance of commerciality is the overall chance that accumulation of oil and gas will be A, discovered, and B, eventually developed. Project is a pretty important term in both COGEH and PRMS. They're required for estimating resources. So a project is really a level that you aggregate to in an evaluation. So you're breaking down. It could be as simple as drilling a well, or it could be as complex as a full development. And the project really defines the ring fence that you're building your evaluation around. It's the full scope of everything from the development costs, operating costs, expenditures, through to the oil and gas assets that are associated with those costs. So this project concept is really what COGEH and PRMS revolve their definitions and classifications around it. So you can see the official definition straight out as a defined activity or set of activities that provides basis for assessment and classification of resources. So when we talk about resources, this can be a little bit confusing because normally most of my discussion is going to revolve around contingent and prospective resources, which is actually a subclass of what this slide is talking about. So resources is literally the entire spectrum of oil and gas in the ground. It includes the unrecoverable, it includes prospective, contingent reserves. All of that falls inside the larger resources bucket. So your resources may be discovered or undiscovered, recoverable or unrecoverable, commercial and non-commercial, and those defining factors really determine whether they fall in reserves or resources buckets. Being a little more specific, prospective resources, petroleum potentially recoverable, undiscovered natural accumulation. So the key there is undiscovered. So prospective resources are really volumes in accumulations that haven't been penetrated by a wellbore, or that it's not known whether they're hydrocarbon bearing or not. So the questions you're going to be asking around prospective resources are, what are the chances of discovery and what are the chances of development? So we talked about those earlier. So both chance of discovery and chance of development apply to prospective resources. Contingent resources, so petroleum in known natural accumulations. So these have been discovered. That's the defining factor between contingent and discovered. And so contingent resources, really only asking what's the chance of development, what's the chance that these volumes are going to be commercial and they will be developed in the future. And the term known, you'll see known in in a bunch of the slides as well. And that really means discovered and recoverable. Reserves, commercial petroleum in known natural accumulations. So again, the key word, the differentiator from resources, contingent resources, is commercial. So reserves have to be viable. So this is really the decision tree for how you classify volumes under. This is specific to COGEH, but you'll see later it's identical in SP PRMS. So you start with the full bucket. So when I was talking about resources in general, this total petroleum in place is every molecule of oil and gas in the ground. The first question you ask is whether it's discovered. Like I said, that's penetration by wellbore and evidence of hydrocarbons. If it is discovered, you then ask whether it's recoverable. If it's not recoverable, it just falls into a bucket that goes in unrecoverable discovered volumes. If it is recoverable, then you have to ask a further question, is it commercial? If it is commercial, you can classify it as reserves. If it's not commercial, it falls into the contingent resource bucket, subject to the commercial contingencies. If it is not discovered, it can only go one of two places. If it's recoverable, it's prospective resources. If it's unrecoverable, it falls into the unrecoverable bucket. That's sort of high level. The formal definitions, there's a little more verbiage to them. They're a little more detailed, but the basic principles are exactly what we've just gone through. So we'll talk about prospective and contingent resources, and then we'll talk a bit about commerciality. We'll get into reserves. So we're back to this McKelvey box, which is basically that decision tree that I just put up in a different format. So this box, like I said earlier, is consistent across all the definitions we're going to be talking about in the next couple of days. This is really the best representation of all of the definitions that we're discussing. So again, you've got the whole bucket on the left side, you've got total PIP, and then it's broken down in discovered and undiscovered, sub-commercial and commercial. So undiscovered, like I said, it's either going to be prospective resources or in the unrecoverable bucket. As soon as it's discovered, it's either going to be contingent or reserves. And the defining factor between contingent reserves is commerciality. On the x-axis, so horizontally, you're talking about the uncertainty in estimates. So you got low, best, high, and so these are the same as 1P, 2P, 3P, as you can see up here. And the concept that this really helps show is that the uncertainty applied to the volumes is identical for all three types. So reserves, contingent resources, and prospective resources. The level of certainty that you apply to the estimates is the same. Your volumes, the actual volumes that you evaluate, should have the exact same degree of certainty. And so what that means is, as soon as you have, say you've got a giant bucket that's undiscovered, you've got a low estimate, a best estimate, and a high estimate that you pull together. As soon as you put a well into that accumulation and it becomes discovered, the volume should not change as it moves from prospective to contingent. The only time the volumes change in 1P, 2P, or 3P is when you have additional technical data. So as soon as you've discovered your known accumulation and you've moved buckets, your low estimate for prospective resources is going to shift directly to the low estimate for contingent resources. And the more applicable, the reason I'm pointing this out is because of the way the guidance has been in North America, where contingent resources were sort of an afterthought until recently, until resource plays became a big deal. Contingent resources were very rarely used. But when they were used, companies were, evaluators, I should say, were a lot more lenient with contingent resources. So they did not put the same degree of discretion on 1P, 2P, and 3P well, 1C, 2C, and 3C resources as they did on reserves. So what was happening was you would have a low estimate contingent resources, they would remove the contingency, and when it went into reserves, they would actually pull back the volumes, which is not the way the definitions are set up. The same rigor should be applied to 1C contingent resources as would be applied to 1P reserves. So on the horizontal axis, when you're talking about uncertainty, the uncertainty rigor should be the same for all three types of volumes. On the y-axis, you've got risk. So this is chance of commerciality, which is risk. So there's two concepts that are very important in reserves and resource definitions, and that's risk and uncertainty. And those are the two axes on this table. So uncertainty is your difference between P10, P50, P90. Chance of commerciality is a risk, so it's a binary switch. It's a chance of failure. So when you're evaluating contingent and prospective resources, you're going to have risk factors based on chance of discovery or chance of development. And those risk factors are to account for chance of failure. So either if you have your chance of development for contingent resources is 80% based on the contingencies you've identified, that's the quantitative number you come up with. That means 80% of the time you're going to get full 1C, 2C, 3C volumes that you've determined for that category, but 20% of the time you're going to get nothing, because it's a binary switch. So that's the difference between uncertainty, which is a gradation of, in this case, volumes, versus risk, which is a binary switch. Okay, so just two more terms that are associated in COGEH and PRMS. There's what's called categorization of volumes, and there's classification of volumes. So the classification is your reserves, contingent resources, prospective resources, and your categorization of reserves is proved, probable, possible. So again, it's the same principles. It's risk on the vertical axis and it's uncertainty on the horizontal axis. It's just when you're going through the actual guidance documents, you'll see the terms classification and you'll see the terms categorization, and that's really referring to where it falls on. For classification, it's where it falls on the vertical axis. For categorization, it's where it falls on the horizontal axis. So same principle, as you can see by the emphasis that's put on how you move through this chart. That's really what evaluators spend a lot of their time doing, is figuring out how these different volumes should be bucketed and how they interact with one another. So you got class on the vertical axis, which is really related to your chance of commerciality. So again, that's your risk. And then you've got the various categories, which is your range of uncertainty, low, best, high. So stepping back to the Petroleum Initially-In-Place, so this is before you get to recoverable volumes, before you get to reserves and contingent resources. You've got the total Petroleum Initially-In-Place, which is the petroleum that existed originally in the naturally occurring accumulation. So that's every molecule that's in the ground. Then you've got discovered Petroleum Initially-In-Place, which is petroleum in known accumulations. Undiscovered Petroleum Initially-In-Place, existing in accumulations yet to be discovered. And when you're discussing these initially in place terms, it's all prior to production, so it includes production. So it's really your total estimate of the volumes that were ever in the reservoir, that were originally in the reservoir. So this is the official definition of prospective resources that you find inside COGEH. So it's petroleum estimated as of a given date to be potentially recoverable from undiscovered accumulations by application of future products. So prospective resources have both a chance of discovery and a chance of development. One thing that we haven't talked about yet, all of the evaluations that are done in the PRMS, most others, are done as of a given effective date. So it's an important part of the evaluation process is to know that it's a snapshot in time. It's not meant to be a moving target. It's meant to say, as of this very specific date and under the conditions that were present at that specific date, this evaluation is reasonable. So all of our evaluations will have an effective date, and that effective date does impact a number of pieces in the evaluation. So examples of prospective resources. Petroleum and seismic anomalies that have not yet been penetrated by a well. So we find that a lot in our evaluations. A lot of times clients will come to us with seismic, but they won't have any penetrations. That's pretty much poster child for prospective resources. Undrilled fault blocks, so heavily faulted reservoirs are also, we spend a lot of time going back and forth with clients, but as soon as you're in a separate fault block, it's a separate accumulation. So the element, if you don't have a wellbore in a certain fault block that we know is not connected, it becomes prospective resources. And then the third one really applies to, we talked a little bit about shale gas. The third one really applies to these widespread resource accumulations. So we have formations like the Montney in Canada for hundreds of miles or hundreds of kilometers. And somewhere in that hundreds of kilometers, even though we know that the reservoir is continuous, we have to put some sort of reasonable bracket around where volumes change from contingent to prospective, or from prospective to contingent to reserves. So petroleum that's a long ways away from a production or a test, even if we know that the formation is continuous and hydrocarbon bearing, can still be classified as a prospective resource. Contingent resources, again the official definition, petroleum estimated as of a given date to be potentially recoverable from known accumulations using established technology or technology under development, not currently commercially recoverable due to one or more contingencies. So a couple of things here. They're starting to introduce the concept of recovery technology. So another one of the hurdles for classifying volumes as contingent resources or reserves is that the technology required to develop the asset or to produce the oil and gas has to have been shown to work in at least similar reservoirs, if not the subject reservoir. That's for reserves. For reserves, it has to be an established technology. For contingent resources, it can be a technology under development, so it can be, a good example is in the oil sands, we're starting to look at solvent injection with thermal processes. And so there's a bunch of technologies that provide enhanced recovery that are sort of in the testing phase. And so those would qualify as technology under development. And once you get into evaluating that, it comes down to a judgment call by the evaluator as to whether there's a reasonable certainty that the technology under development will be able to produce the asset. One or more contingencies. So we'll be talking about what constitutes a contingency, but it's basically a barrier to commercialization, and we'll be going through some examples. So a contingency, the official definition, a condition which must be satisfied for a portion of discovered petroleum initially in place to be classified as a reserve. It's specific to whatever project you're looking at. And there has to be an expectation that the contingency will be lifted. If there's no expectation for the contingency to be resolved, then the volumes are either going to fall recoverable or preserved. Typical contingencies, economics. So a lot of times, if under current conditions, future development or even production becomes uneconomic, it can't be classified as a reserve because it's no longer commercial, so it falls into the contingent resource bucket. Lack of a market, if you have nowhere to sell the asset or no way to get the asset, and no way to get the oil or gas to sales, that could be a contingency to a sales point. Corporate commitment, if the company has no plan in place or no firm corporate commitment within a reasonable time frame to develop the asset, that can be a contingency. In a similar vein, development schedule too far in the future. So if a company evaluates an asset and says, we're going to develop it, but it's not going to be for 15 years, and there's no specific reason other than it's a low priority in their portfolio, that can be a contingency. Regulatory approval, another one, if the government will not allow, well, if there's reasonable certainty that the government will approve the project eventually, it can be a contingent resource. The government is not going to, if there's no precedent for the government to give regulatory approval, again, it can't be a contingent resource, it would have to fall into unrecoverable or prospective. So what can't be called contingency? Lack of ownership. So if you, in Canada, we have a lot of what we call farm-ins, where a company will have to meet some specific capital requirements to earn land. If you don't, even if you have a farm agreement that says we will give you the mineral rights to this asset as soon as you complete X, Y, and Z, even if it's forthcoming, you cannot book contingent resources, prospective resources, or reserves if there's no mineral ownership. So the company that's being evaluated has to have the ownership to the asset. Lack of knowledge of properties of reservoir. So just because you don't have enough data can't be a contingency. It's either going to fall, there's either going to be too much risk and it's going to fall into the prospective resource bucket, or you don't have enough information to determine volumes at all, in which case you're way back in the process, and lack of technology for recovery. So there are a number of assets. 15, 20 years ago, shale gas and shale oil would have fallen into this bucket. If you know it's there, you can penetrate it, you can produce a little bit, but you don't have a technology available to you that will allow you to develop the asset, that's not a contingency. Again, it would fall in the unrecovered portion if that was the issue. So a couple of examples of Canada. We have some large offshore projects off the east side of our country. Contingencies out there relate to things like infrastructure, regulatory approval, timing, and economics. So they're very large projects, very capital intensive, and in order to book reserves, you would have to remove a lot of these issues. But you can book them as contingent resources as long as you specifically identify what those contingencies are and what the company is doing or will do to those contingencies. Oil sands developments are another big one. Timing, regulatory approvals, corporate commitment. Again, when you're getting into very large development schemes like these, it's very capital intensive, and so they're generally good candidates for contingent resources because they're viable projects. There's just some major hurdles to get over in order to produce the assets. So in those cases, you identify the contingencies and you can at least disclose the volumes. You can show investors, you can show your bankers the potential size of the prize for your large project. Project maturity subclasses. So this is starting to get subclassification of reserves, contingent and prospective resources. And these are really buckets to identify, again, in the resource case, levels of risk. In the reserves case, it's more development status. So in the reserves case, you have on production, you have approved for development and justified for development. So there's no risk associated with those. It's just a question of at what stage of development the assets are in. For contingent resources, you have development pending, which is assets that you have a fairly well-defined development plan for. You know basically when it's going to be developed, how it's going to be developed. It's very well-defined. Then you have development on hold, where for one or more reasons, you're not currently actively pursuing development of the assets. It could be economic conditions, it could be the markets. So you've placed your volumes on hold. Development unclarified is where you have less defined path to producing the assets. And development not viable is the bucket where you have a bunch of assets, but you have no way to fund or develop them. You haven't pursued. You probably need to do something like a JV. You need to raise a bunch of capital. You need to. There's no corporate plan currently to develop the assets, and they're not. Prospective resources are split into what they call prospect, lead, and play. The definition of prospect lead are fairly high level, and they basically are associated with what stage information gathering you're in the project. So at the bottom at play, you have very little data on the project, and you're really working on a data acquisition phase. Lead and prospect, you're starting to get a bit more information, and you're starting to move towards the discovered and contingent resources. Project maturity subclasses. So again, just going into the actual definitions for contingent resources, these are the ones that we actually spend most of our time with disclosures. In Canada, you're allowed to disclose contingent resources, and in the last couple of years, there's been a lot more scrutiny on contingent resource disclosure. And so they're now forcing anyone who's disclosing contingent resources to define the volumes into these maturity subclasses. So pending high chance of development, resolution of contingencies being actively pursued. So these are volumes they're usually, take for example, our oil sands project, they happen in phases. They're such large assets and such large capital expenditures that they have to be built in phases. So phase 1 might be on production, it might be reserves. Phase 2 might be currently under development, it might be undeveloped reserves. And then phase 3 and 4 might be a little further down the road, they might be a little further away and require more infrastructure, etc. So they may fall into the development pending subclass of contingent resources. So it's kind of a scale, and that's really the intent of subclasses, is to allow investors and stakeholders to see qualitatively how far up the risk scale these assets are. So they can look at a contingent resource and they know right off the bat that development pending contingent resources have a lower commerciality risk than unclarified or not viable. So the whole point of these buckets is to give people relatively quick understanding of what level of commercial development or what level of commercial risk is associated with the volumes. So I basically talked about most of these, so I'll skip through them. On hold, unclarified, and not viable. So like I said, not viable is just assets that they've been looked at. You know that they're contingent, you know what contingencies they're subject to, but you really have no plans to address those contingencies. Why a resource and not a reserve? This is going back to those risk factors. So again, prospective resources, there's two risk factors. There's chance of discovery and chance of development. Contingent resources, there's only one condition, that's the chance. So that's what segregates the three types of volumes into the three buckets. So getting into reserves, the official definition, petroleum anticipated to be commercially recoverable from known accumulations as of a given date, based on the analysis of geological, geophysical, and engineering data using established technologies under defined economic conditions. The economic conditions have to be reasonable and they have to be disclosed. So again, it has to be established technology, so there's a bit more stringent definition of what reserves in terms of technologies. There's been some issues in Canada in the last 4 or 5 years with the definition of established technology, and evaluators booking technology have not been demonstrated to be commercially viable in the subject reservoir. A good example is thermal recovery processes in carbonate reservoirs. So pretty much all the thermal applications in Canada and throughout most of the world are in sandstone reservoirs. And recently there's been some pilot projects in Canada to implement thermal assets, carbonate reservoirs, and one of the major Canadian evaluation firms got into some trouble with the ESC because they booked reserves and some contingent resources before the ESC was comfortable with the definition that they were meeting the definition of established technology in the subject reservoir. So the technology side of things has been a bit of a hot topic in Canada for the last couple of years. Characteristics of reserves. So very quickly, they're known. Like we were talking about, they're discovered, they're recoverable, they're economic. The definition of economic is slightly different in the different guidance systems. In COGEH, it says it has to provide a reasonable rate of return to the company. So COGEH basically says the cutoff can't be and the reserve can't be undiscounted. There has to be a rate of return associated with it. They're commercial. They're remaining as of effective date, so that means that historical production doesn't classify as reserves volumes. They're owned, so we talked a bit about ownership. They're producible, so they have all of the regulatory and government and political environmental approvals that they can produce the asset, there's no question. So again, going into commerciality, there's a lot of different things that can qualify as contingencies and keep volumes from becoming commercial, including political, legal, regulatory, and contractual issues. So if any of these are sticking points or any of these are problems for the company, you're again looking at that contingent resource bucket. You're not looking at reserves if you can't get approval in all of these various categories. Essential conditions for commerciality. Economic viability of the project. Like I said, COGEH says you have to have a reasonable rate of return that qualifies reserves. So if you don't have a reasonable rate of return, then under COGEH, it's not commercial. You have to have done your due diligence on market, production, and transportation. So depending on what the market cycle looks like, this can actually be an issue. In Canada especially, we have a fairly limited market right now for natural gas. So natural gas and byproduct off-taking can cause issues. So if a company has a massive asset like the shale gas asset, like Montney, but they have no way to, because we know that the market is saturated with gas and byproducts, it's mostly byproducts right now. If they have no way to offload those byproducts or sell those byproducts, then they can't be classified as reserves. So it's another, in large places like the Montney, companies might have thousands and thousands of viable locations that they can drill, but because of the market constraints, they may not be able to book them to reserves, and in some cases even contingent resources, just because we know there's going to be issues with the byproduct market in the future. Reasonable expectation of internal and external approval, and evidence of reasonable timetable for development. So reasonable timetable for development is defined in COGEH for proved to be 3 years, and for proved plus probable to be 5 years. So if you have undeveloped or non-producing assets, non-producing it's even more strict. Non-producing, they say within 2 years it should be dealt with. So if you have timetables outside of 2, 3, and 5 years, you can still book reserves, but again, you have to disclose why you're booking reserves outside of the recommended guidelines, and there has to be a good reason for it. It happens quite regularly. Makes your timelines. Again, if we go back to the Montney, where we have large production volumes of gas, a lot of times the gas production and the drilling of new wells will be constrained by facility constraints and facility throughput. And as long as you have done your evaluation in what's called a drill to fill scenario, where you are only drilling wells at a pace that will allow you to keep your facilities full, you can book well beyond the 3 and 5 year limit for reserves. But you have to have a good reason, and you have to disclose why you booked beyond those limits in your. So classification of reserves, there's a number of different classifications. You've got the degree of certainty, which we've talked about, proved, probable, possible. Status of development, you've got developed reserves and undeveloped reserves. Status of production, you've got producing and non-producing reserves. In terms of the certainty, so proved reserves is a high degree of certainty. So that's a deterministic definition of proved reserves is a high degree of certainty. It's likely that the actual remaining quantities to be recovered will exceed the proved reserves. So 9 times out of 10, you're going to get more than your proved reserve estimate out of a well. If you have a probabilistic estimate, it's your P90. Probable reserves, it's less certain to be recovered than proved reserves. That's actually the terminology out PRMS, but it's virtually identical in COGEH. In COGEH, it's the second line. It says it's equally likely that the actual remaining quantities will be higher or lower than the estimate. And if you're doing a probabilistic evaluation, it's your P50. Possible reserves, again, less certain than the probable reserves. It's unlikely that the actual remaining quantities will exceed the booked volumes, and it is your P10 if you do a probabilistic evaluation. The intent of the certainty classification. So this is when we'll talk a bit more about how you determine whether companies and evaluators are doing a good job in sticking to the definitions. But this is one of the easiest ways to tell if you have a few years of performance of reserves. So proved reserves, generally speaking, should be going up over time. And this is talking about technical revisions. It's not talking about adding new volumes or extensions or infills. It's talking about revisions to existing forecasts on a proved basis. They should be going up, almost always. Proved plus probable should be fairly neutral. So there should be material increases or decreases over time to your proved plus probable. And the 3P should be negative. So what should be happening over time is the central limit theorem. It should be coming, your high and your low estimates should start to converge towards your best estimate as more information comes available. This is the terminology read out of COGEH. COGEH says that proved reserves are a conservative estimate of reserves. Proved plus probable is the best estimate, it's about right. And proved plus probable plus possible are an optimistic estimate of reserves. So it's saying the same thing a different way. It's saying that proved reserves are conservative and you should exceed them. Possible reserves are optimistic and you're probably going to come in below them. And proved plus probable should be about right. Developed reserves. So this is getting into developed, undeveloped. So we're just moving through all the different classifications of reserves. So developed reserves are expected to be recovered from existing wells and installed facilities, or facilities that have not been installed that would involve low expenditure in comparison to the drill cost of a well. And through installed extraction equipment or infrastructure that is operational. So basically what this is saying is in order to be classified as developed reserves, you can't have any major capital expenditures remaining. They should be on production, the infrastructure should be in place, and there should be no major capital spent for developed reserves. The definition for developed reserves is slightly different in PRMS. Not so much in this sense. It's the same in terms of the capital requirements, but developed reserves in PRMS also have some production requirements that we'll talk about later this afternoon. So developed producing reserves, expected to be recovered from completion intervals open at the time of estimate, may be producing, or if shut in, must previously been on production, and the date of resumption known with reasonable certainty. The reason this second point is is highlighted is because PRMS, so PRMS, this is the first part, PRMS is an estimated commission interval that's open at the effective date of the report. COGEH says it doesn't necessarily have to be on production at the effective date of the report, but if it's not on production, it has to have been on production at some point, and the date of resumption of production has to be with most certainty. There's a slight difference between COGEH and PRMS, but producing reserves are essentially wells that are on production. Developed non-producing reserves are either reserves that have not been on production. So, good example, in Canada, a lot of times at the end of the year, companies are drilling wells and their disclosure effective date's December 31. A lot of times, wells will be drilled but not yet completed, or they'll be drilled and completed but not yet on production by the effective date of the report. If that's the case, they have to fall into the non-producing category. You can't assign them as PDP reserves, or developed producing reserves. It can also be wells that have been on production but are currently shut in, and the operator doesn't know when they're going to go back and turn them back. So they don't have to have a capital requirement. Normally, developed non-producing does have a capital requirement. There's usually some small amount of capital to bring them on, but it is possible. Sometimes operators will shut in wells if market conditions are not good enough. Gas prices or oil prices drop. Operators temporarily shut in wells, and if they do that, they can be classified as PDNP even if there's no capital required to bring them back on. Undeveloped reserves expected to be recovered from no accumulations or significant expenditure when compared to the cost of drilling a well. So again, the difference between developed non-producing and undeveloped is really the magnitude of capital expenditure. And the hurdle that COGEH puts in place is the cost of drilling a well. So if it costs a company $100,000 to drill a well, and they have $100,000 of tie-in costs or infrastructure costs remaining to bring the well on production, then that would have to be classified as undeveloped. But if it costs $100,000 to drill a well and they have a $20,000 completion rate, then it can be classified as PDNP. There's wiggle room for the evaluators to determine more material in relation to drill cost, but it's pretty cut and dry whether it should be classified as undeveloped or developed non-producing. Basically what this is. So developed reserves need little or no capital compared to the cost of drilling a well, whereas undeveloped has significant capital still required to bring the volumes on production. So this is just a flow chart showing proved, plus probable, and 3P, developed and undeveloped, producing, non-producing. Three headings there are classifications of reserves. So certainty, development status, and production status. So ownership, and this is more about disclosure. So COGEH defines company gross, company royalty, company net, and company interest reserves. And then NI 51-101 or SEC will choose which categories have to be disclosed in their disclosure. So company gross is all of the working interest prior to deduction of burdens and royalties. Company royalty interest, when the company actually owns the royalty interest, so it's only the royalty interest amounts that the company owns. Company net is working interest after deduction of burdens and royalties. And company interest is company gross plus company royalty. So company interest is the total volumes of the company that are attributable to the company. NI 51-101 has company net volume, so it's their working interest after deducting burdens. Other reserves considerations, drilling requirements. So we've talked a lot about known accumulations and penetration by wellbore. Testing requirements. So in order to be classified as commercial, you have to have evidence of commercial productivity, of commercial. So a lot of times a company will drill a well, it'll be sitting there uncompleted, and whether or not it can be classified as reserves will come down to what sort of data they can show us that the well is capable of producing at commercial rates. Timing of production and development, we talked a little bit about that. 2 years for PDNP. There is an exemption to that if the proved developed non-producing formation is an uphole formation in the same wellbore, and it's just waiting on completion or depletion of the other zones, then you can PDNP entities that are 15 years out if that's when the forecast for the currently producing zone ends. And then three years proved and 5 years probable for most applications under COGEH. And again, 50-year forecast period that we talked about earlier, so all reserves are to be recovered within 50 years unless there is a very specific reason. I've never actually seen an evaluation that goes beyond the year for reserves. So this is the final slide for this section, and it's really a high-level summary comparing the three different buckets of volumes. So it just really summarizes exactly what we've gone through and what the definitions do for prospective, contingent, and reserves. Big difference, potentially recoverable versus commercially recoverable. Again, that's your difference between resources and reserves commerciality. Undiscovered versus discovered. That's, again, prospective versus contingent or reserves. Future development projects, so prospective resources, you don't need an established technology. You need a reasonable approach to development project. Contingent resources needs established technology or technology under development, and reserves, it must be an established technology. And going back to the risk factors, 2 risk factors for prospective, 1 risk factor for contingent, and no risk associated with reserves volume. So that is the COGEH definitions.